All right, good morning, guys. Today is Monday. Monday. What is it? June 1st, into June. It's my mom's birthday today. I should give her a call. All right. We have basically 2 weeks left, guys. Starting today, we have 2 weeks left. So work hard as we finish up here. We have a lot of stuff still to cover. Today's the last day we're going to be talking about multiplying fractions. If you're not already to the point where you're multiplying numerator by numerator, denominator by denominator, we need to get there, right? Because that's the shortcut way. But we need to understand why we're getting it drawn in the models. When we talk about multiplying by these mixed numbers, the biggest thing is that when we're multiplying by mixed numbers is that we're multiplying the whole part by the fraction part, right? Okay, as well as the fraction part by the whole part. Okay, so I'll go over a little bit of that today and try to make that a little bit clearer for us, and hopefully it makes more sense. So let me go through an example here real fast. Some students had different questions on some of these problems. So last week on Friday, because I didn't post a video, it's all the same stuff that we've been doing, just maybe a slightly different way of looking at things. So let's go ahead and look at a problem here. Let me grab a piece of paper. I'll do it in the book, it's fine. So if we look at number 6 here, let's just start here. Okay, it says Izzy has 3.5 yards of rope. She uses 3/5 of the rope. So she's not using 3/5 yards. Okay, she's not using 3/5 of a yard. That is not the length of the yard that she's using. Okay, that is one common thing that kids make mistakes of. They think this is 3/5 yard, and so they think, oh, this is how much she has, this is how much she used, so I just need to separate this from this to see which how many yards is left over, whatever. But no, the idea is how many yards does Izzy use to use for the tire swing? Well, right here it says she used 3/5. So the answer is 3/5. No, it's not. She didn't use 3/5 yards, right? She used 3/5 of this, 3/5 of the rope. Okay, this is the rope, so it's 3/5 of this. We could replace this with the word of the rope part. We could replace it with 3.5, right? So 3.5 it would go here. So 3/5 of 3.5. Okay, that means that I'm going to multiply because it's talking about of, right? Okay, 3/5 of a fraction of something. Okay, part of something. Okay, so what I'm looking at here is I have 3/5 times 3.5. What I should do though, when I look at this, I should rewrite my mixed number and go ahead and separate it, right? Just like we would place values, it's the same concept here, okay? So if I go and separate this into 3 plus 1/2, I get it into 2 separate parts, okay? Then I'm going to go look at this as, this is like this, right? By separating this, it kind of shows that it doesn't matter if I add it and multiply or if I multiply and then add it, it'll work both ways, okay? So what I want to do is I want to do 3/5 times 3, do that, and then I want to add that to 3/5 times 1/2. Now, I want to multiply first. I'm going to do these parts first. I'm going to add that answer together, okay? All right, so what I'm going to do here is, let's go and do this one first because this one's just multiply across, right? So this would be 3, this would be 10, right? Good, yep. Over here, now this one's a little bit different though, right? This one's a little bit different. We need to go ahead and change this into a improper fraction if we want to see it that way. Now, if you know that it's this way, we can just multiply 3 times 3 and get 9/5. The reason why that works is because if I change this into a fraction, it becomes 3/1. 3 wholes is 3/1, right? Then if I multiply across, it's 9 and 5, right? So 9/5. So then I just need to put these together. Obviously, when I add these, I need to find common denominators. There's other ways to do it so you don't have to worry about that. And that would be if I turn this whole thing into a mixed number, and then you could avoid not having common denominators. But then you have to convert it back into a mixed number. So we can do it either way. It works, right? So I'll do it just this way on this problem. The next problem I'll do it differently. Okay. So again, 9/5. If we're going to change this, this is equal to. We're going to leave this as tenths because this is fifths. We can change that to tenths. So I'm going to multiply this by 2. 2 halves, which is the same as 1. So we get 18 tenths. Okay, when we put this together, we get 21 tenths, which is equal to 2 and 1/10, right? Okay. So that is the answer for that problem. Okay. So I got a different strategy for this one then, okay? A different strategy for this one. Okay. Instead of breaking it into 2 problems like this, I'm just going to convert the mixed number into an improper fraction and then multiply, okay? So Colin has a chain that is 4/5 foot long. He adds links to the chain so that it is 4.5 times as long as the original chain. How many feet long is the chain now? Well, he adds links to so this chain, which was 5 6 foot long, this chain is now 4.5 times longer. So it means 4.5 times. We're going to multiply by 4.5, right? Okay, that's our problem. If I'm going to rewrite this into so it's a mixed number, you get 5 6. Okay. Now, if I'm making this a mixed number, the idea is that each of these is since these are halves, we're going to treat these as two halves each, right? Which is 8 halves, correct? Okay, so 8 halves has to be 9 halves because I added this. Okay, honestly, a shortcut that a lot of people use. Okay, they multiply this and they add this. So it'd be 2 times 4 is 8 plus 1 is 9. Okay, that's just a shortcut to change it between a mixed number and a improper fraction. Okay. So we should get this. Okay, but the idea is that is 8 halves. Okay, 4 holes is right is 8 halves because 4 over 1. Okay, right. If we in this, well, it's 4 1, but if we want to get it to a common denominator there, is equal to 8 halves because this would be times 2 and this would be times 2, right? So it's an equivalent fraction. Now when we multiply here, we multiply straight across. This we get to 12ths, this we get to 45ths. So we have 45th 12ths. Okay, now with 45th 12ths, I need to go ahead and turn this back into a mixed number, don't I? Well, how many groups of 12? This is basically 45 divided by 12. We know that 4 groups is 48. 4 groups of 12 is 48 because 4 times 12 is 48. So we're going to do 3. That's not big enough. So we know we're going to have 3 as far as our whole goes, right? Okay. So then my next question is, okay, so if I have 3, this is 3 times 12 is 36. Therefore, what is 45 minus 36, right? Well, 45 minus 36, I can see quickly that these numbers here this is 1 less than this one is 1 more than this one. I know that if this was a 6, that'd be 10 off. Because it's not a 6, I'm 9 off, right? So it's going to be 9/12, okay, which is a correct answer, but not the best answer. We need to simplify. So we can go ahead and divide both the numerator and denominator by what number? Yeah, 3. So this equals, if I divide this by 3, I get 3. If I divide this by 3, I get 4. So 3 3/4. That is the best answer for this problem. So as you can see, we did 2 different strategies to attack this problem. There's a lot of different ways we can look at it, obviously. Okay. Now, if we look at the bottom down here, this was one Riley was asking about, saying that she didn't get it. And so that's no problem. I'm going to answer this one for you, Riley. So hopefully you're watching. Okay. So George has 1 5/9 yards of fabric. He plans to use 3/4 of the fabric, right? Again, the fabric is 1 5/9, right? So this is saying 3/4 of 1 5/9. Okay, to make a pillow, how many yards of fabric will he use for the pillow? Okay, so what we got here is we have 3/4 times 1 5/9, because it's of, right? It's 3/4 of this amount, and this will give us a number that's going to be less than, we know our answer is going to be less than 1 5/9, right? Our answer is going to be less than 1 5/9 because we're multiplying this by a fraction that's less than a whole. So we know we're going to have less than 1 5/9, right? So if there's any of these out there that are more than that, then we know we're wrong, right? So let's go ahead and see. Let's go ahead and see if we, how do we want to attack this problem? I would attack this problem by looking at this one here and being like, okay, well, that's easy to work with multiple ways because it's 1. I know 1 times 3/4 is just 3/4, right? So that's one way I can look at it. I could also look at it from the standpoint of, I can quickly turn this into a improper fraction as well, just because there's a 1 there that makes it a lot easier to work with. Ultimately, it doesn't really matter as long as you go through the whole process either way. Okay, I'm going to go ahead and use our first process so you see this in a different way. So it's going to be 3/4 times 1 plus 3/4 times 5/9. Okay, so then here, obviously, this is just 3/4. Okay, and when I multiply this, I get 3 times 5 is 15. Okay, then I get 4 times 9, that's 36. All right. And so now I have 3/4 plus 15/36. Well, here's the thing. We can obviously get this to 36, then add, and then simplify. That would totally work. Okay. So we know 4 times 9 is 36. We can just multiply this time and multiply this to get 27, 36, then add that, and then simplify. Totally will work. I could also just go ahead and simplify this first and then find common denominators as well. Doesn't matter. Either way, whatever order we do that, it's going to get to where we need to get to. So let's go ahead and just convert this, and we'll multiply this by 9/9 to get the equivalent fractions. That will get us to 36. That equals 27/36. So now I have 27/36 plus 15/36. And I add this together, I get to 42/36, right? 42/36. Okay. Now, if you did the strategy I was talking about down here, you might be getting an answer that is different than the answers here that I'm seeing. And maybe that's what was bothering you, Riley, because you're going to answer as maybe a better answer than the options here. I think the book is ideally looking at you doing something like this for it. So when I get this number here, I need to convert it. So if I take 36/36, that makes 1 whole. What's left over? So the idea, I'd be taking 42 minus 36 to get what's left over in my numerator spot. Well, again, if I recognize a pattern here, this is 6 in the 30s. This goes up to essentially the next 10 and to 2. So we know that we treat that like 6 to 12. We know that's another 6, so that would equal 6. And so this would be 6/36, okay? Which obviously that answer is right here. Okay? Now, of course, you know me. My best answer is going to be divide both those by 6 and get to the simplest form. It should be 1 and 1/6 is the best answer here. But it's not an option here, so the answer would have to be A. So if you did this in a different strategy, like I was talking about, if you simplified here first and you just got this down to another number, so you divided both of these by 3, let's say, you get down to 5/12, okay? And then you work from there. Obviously, you're going to number that's going to be at a different amount, so you're going to have to adjust it in things like that, but it's not going to show this. You just have to understand that there would be an equivalent fraction there. Okay, I'm not going to go over these pages. Again, this is talking about the strategy I just used. So again, actually, I will just do this first part here. Okay, so in this problem here, it's 3/4 times, what is it, 2/3? Okay, times 2/3. This would be 2/3. This is the same as 3 times 2/3 plus 1/4 times 2/3, right? Okay, so again, then this 3 times 2/3 is 6/3. Okay, again, if we wanted to, we could write it like this, so we can see that that's how we multiply. We're just multiplying the whole number by the numerator. Okay, then over here, we have 1 times 2 is 2. There's our 2 there, right? This would be 12. Okay, right? Then when we add this all together, well, that's 2/12 is going to go right there. But this 6/3 is just 2, isn't it? 6/3 is just 2. So it'd be 2 and 2/12. Okay. Now, ideally, again, we'd want to simplify that to 2 and 1/6, even though the book does not show that as the answer. It's frustrating for me. I don't know why we wouldn't be simplifying. We've been doing it all year long. Why would we stop doing it now? Okay. Now, so hopefully that helps a little bit. Apply some of these concepts here. Obviously, if you have more questions and I didn't answer a question on a certain problem that you want to discuss, I'm happy to answer, to come on with me at about noon today, so we can work. Today is, like I said, June 1st here, 453 to 456. It's going to be your assignment today. Again, there are 4 pages, but there's only 7 problems. I really don't care if you do the math journal page, guys. Do it if you want. Obviously, you don't need to, though. But there's only 7 problems in, okay? And after that, starting tomorrow, guys, we're going to get into dividing fractions, okay? And concepts of dividing fractions. So it's super important that you finish strong here with multiplying fractions. And then when we get into dividing fractions, so we're probably not going to be coming back to multiplying fractions very often, as we only have 2 weeks left of school. We got to get through all this other stuff. Okay. Let's do number 1 together, and then you can do the rest of them. Then I'll leave you 6 problems here, okay? Let's look up here real fast, though, first. So just in the example here, Chris uses 4 1/4 tubes of paint. Nico uses 1.5 times as much as Chris uses. So he uses 1.5 times as much. Okay, so the idea is that we're going to multiply 4 1/4 times 1.5. Now you might be on, wait a second, this is the first time that we've done a mixed number times a mixed number, right? And you're right, it is the same. I mean, this first time we've done mixed number times a mixed number. So let's look at what they did here. So what they did was we have to multiply 4 1/4 times 1.5. That means we have to multiply both parts, the fraction of the whole number by the fraction of the whole number over here. We have to do the whole thing. Okay. A common mistake kids make is they would multiply 4 times 1, and then they multiply 1/4 times 1/2, and then whatever their answers they get here, let's call it A and B, then they would do A plus B. That's what they would do. They would multiply the whole numbers together, then they multiply the fractions together, but that does not work. You have to multiply the whole number by both the whole number and the fraction, and then the fraction over here by both the whole number and the fraction. The whole number has to be multiplied together. So what they did here in this problem is they went ahead and took 4 1/4 and multiplied it by 1. That's both parts of it, the whole entire number multiplied by 1. Then they took the whole entire number and multiplied it by a half. So that's why they have 4 times a half, 4 times a half, plus 1/4 times a half, and they're going to add that together. Okay, they get 2 1/8, right? And then they're going to add 4 1/4 with that. Okay, and so then go through the process. Okay, well, we know that 4 1/4 plus 2 is 6 1/4. We need to add an 8, so we need to convert this to eighths, and that's how we get to our answer. So look at that closely, please, because again, that's going to be this is going to be the tricky stuff, is when we have problems that are mixed numbers like that. Actually, let me go ahead and look for a problem that actually has. There's Probably not enough members that actually are practicing that, which is an annoyance of mine. Because I think it's an important one to practice here. Here, let's look at number 6. So this is the one I'm gonna do here with you. Okay. It's here. Jill draws a rectangle with the dimensions shown below. What is the area of Jill's rectangle? So 2 2/5 units, length and width, right? 4 and 1. So if we find the area, we're length times width here. So we're doing 2 2/5 times 4 1/8. Now, if you're wondering, Mr. Swatches, can we just turn these both into improper fractions and then multiply and then convert them back into mixed numbers? Yes, absolutely. Absolutely. So let's go ahead and use that strategy as well. Okay, so let's go and do that first. Okay, so if I make this into improper fraction, okay, this is going to be 12/5. And I got there because 5/5 is 1 whole, right? So 2 wholes would be 10/5 plus 2/5 is 12/5. We're gonna multiply this by, this is gonna be, and again, I talked about that shortcut being 8 times 4 plus 1, right? So 8 times 4 is 32. 32 plus 1 is 33. So 33/8, right? See, the problem with this strategy, hopefully you're already seeing the problem with this strategy, is that all of a sudden now I have quite large numbers to work with, don't I? Now I have 12 times 33, and that's what I have to do. Not as cool as it. It's not as much fun. We can still do it. We can do 33 times 12. Again, this is going to be 66 because that's by 2. Then down here is going to be 330 because it's 33 times 10. If I add this together, I get 396. That's a 6. Okay, so I would get 396 40ths. Again, now I'm in a situation now where I now have this big awkward number that makes it again harder for me to work with. If I look at this as 396 divided by 40, I could write a division problem, or I could just think critically here, how many groups of 40 are there? Well, I know that 10 groups of 40 would be 400, right? Well, that's really close to this number. So I know it's going to be 9. So I have 9 as my whole. Okay. I can also double check this, just saying that, hey, look, 4 times 2 is 8. When I multiply these other fractions of the whole numbers, that's going to make more of it. So that seems reasonable already. What's left over? If 10 times 40 is 400, what's left over? Well, the difference between that would be what? The problem is that we can't just do that, can't we? We have to be able to go ahead and look at this as, I was have to go and look at this as 9 times 40 is 360. So that's what we got to find that separation, which is 36, right? Okay, it should be 36 40ths. We got to simplify that now. That would be 9. And let's see here. That'd be 18. 18 20ths, which can simplify down again to 9 and 9/10. I think I did that right. Let me double check, make sure I'm giving you guys good information here. Dun, 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 dun. Oof, got it. So yeah, the point is that this way would have worked. Another way we could have done this, when we were at this point, we could have simplified this instead of converting it right then. We could have simplified this as well. If we simplified this, we could have got it down to, let's see, both these numbers could be divisible by multiple numbers, but we could have divided this by 2. So we got this down to 20 first, maybe. Then half of this would be, let's see here, half of my 396. So half of that would be, oh, let's just do this real fast. Dun, dun, dun. Half of this would be, let's be 100. Let's just do that. 96. 90, be 80, there goes 16 left over, which would be 198, 198, and then we can simplify this again as well, which maybe it's not an easier way to do it, just we could do this, giving you lots of multiple strategies to approach this. We could do this again and simplify this again, or we could say, hey, I can just do like we did earlier with this. But if I did simplify it again, this would become, I believe it would become 99 tenths. Yep, it'd become 99 tenths. And then from there, from here, we couldn't simplify it anymore, but then we would be able to convert it 99 tenths. Again, obviously we could write that as a decimal, but when it asks us to write it as when we're asking everything is in fractions, keep it as fractions. Don't switch your answer into decimals, please, okay? Unless it asks you to do that, okay? I'm gonna grab a scratch piece of paper because now I want to show you how to do it the other way, because I know that might have been confusing to some people. Grab a switch to a page that is a scratch piece of paper. Okay. So the problem is 2 2 2 2/5 times 4 1/8, right? Okay, so this is what we're dealing with here, right? Our goal is to get the answer of 9 9/10. So let's see if we can do that. So let's go ahead and take this, and let's go and let's separate the 4 and the 1/8. So we're gonna go 2 2/5 times 4, okay? And then we're gonna go 2 2/5 times 1/8, okay? So that is, if we do this and we add these two parts together, we should get our answer, right? So this is going to equal 4 times 2 is 8. And 4 times 2 is 8. Then we do 4 times 2/5. Well, again, I multiply this by the numerator, right? So I'm going to get 8/5. So I can leave that I'm just going to leave that as an improper fraction now. That's okay. I could change it, doesn't matter. I'm just going to leave it as is for now. It'll be easy to change if I wanted to. Okay, so that's the first part, right? Second part is going to be the 2/5 times the 1/8. So it was all of this times this. This was A. Here's A, right? Then it was all of this times this, and this is B, and here's B. Hopefully that makes sense. Some of you might be like, well, this strategy is way better than the one you just showed us. And it might be. I mean, like I said, the numbers don't get as big to work with. So it kind of keeps it a little bit simpler. Now, again, when I multiply this, I'm going to multiply 1/8 times 2, right? Which is 2/8. Oops. Okay. And then I'm going to multiply, which I'm going to go ahead and add this to this other part here, right? Because it's not as easy, because it's not going to be a whole number, right? 1/8 times 2/5, which is 2/40, right? So if I put these two parts together, 2/8 to 40ths here, I guess we'll go to 40ths, that's fine. So multiply this by 5, multiply this by 5, so that'd be 10/40ths plus 2/40ths equals 12/40ths. Okay, so then I have 8 8/5 plus 12/40ths, right? Okay, all right. Again, I have to do a little bit of work in this. Is why we did all the um, common denominator stuff before we got to this stage, right? So we can always go to 40ths here, or we can simplify this as well. We can always convert this over. We can do this in any order we want at this point, okay? So this is what I'm looking at here, okay? I might just go and change this into 9 3/5 plus 12/40. Might be easier to work with here. Yeah. Let's go ahead and get this to, this will just go to 40ths, that's fine. So 9, and this will be, if I go to 40ths over here, I have to multiply this by 8, right? So 8 times this is 24. I know I could have went to other ones as well, but just to keep it simple so I'm not losing too many people here. When I add these together, I have common denominators, so that stays as 9. and 24 plus 12 is 36. 36/40ths, which is great. I can simplify both of these. Both of these are divisible. Oops, I'm sorry, you can't see that. Okay, so anyways, that's what I got here, right? Both of these are divisible. Both of these are divisible by 4. So if I divide 36 by 4, I get 9. 40 by 4, I get 10. Therefore, it's 9 and 9/10, right? 9 and 9/10. Multiple ways to look at this. Again, do the way that makes it simplest for you, that you understand the best. Again, if you feel like these bigger numbers, you're like, oh, that's fine. I can work with that. That's not a problem. I'd rather just do that than deal with the holes and then do that. If you're like, man, I want to keep it in smaller, manageable numbers. Okay, then you can do it more similar to this, right? There's a lot of different ways you can do this. There's not just one way, and there's other ways beyond that. If you wanted to draw it out, you could, to model that. It's just so many different ways you can look at these problems, kids. And so it's up to you to decide kind of how you want to approach it, but you need to practice, okay? You need to practice this stuff. Some of the stuff takes time to get used to, because it is quite different. I know it's going to be harder to learn some of these things on your own at home. So this has been a really long video, and I hope it helps. I'll be on at noon to give you guys a hand if you need anything. Talk to you later. Bye-bye.